Okay guys, here's the video on notes on mean and median. Unfortunately the file's a PDF and the pictures aren't coming out because it didn't come through correctly through Google Drive, but you have it in front of you hopefully, and I'll just walk through this top portion. You've done mean and median before, obviously, many times, so these notes are a little bit more of an introduction to the symbols that we use, some of the most popular symbols we use in statistics, and then also maybe some different ways to think about mean and median. So this top symbol here that represents the sum of the values in a data set is the Greek letter sigma, capital. You've got a uppercase N for population size and a lowercase n for sample size. That's the number of data points in the data set. Mu, I draw it this way, it looks like a little U. That's the Greek letter mu. That represents the mean of a population. The mean of a sample is X bar, we call that. The median of a population is X tilde, and the X is uppercase because we're talking about a population. And the median of a sample is lowercase x with the tilde. And those are some of your common symbols. Again, you found mean before, but it is interesting to think about mean as a balance point or a center of mass, if you were thinking of a physics principle. The weight of the data, not the number of data points like the median, but the quote-unquote weight of the data is the same on either side of the mean, and that's why when you have outliers to one side with a skew data set, it's gonna be farther away from that balance point, right? So it's gonna pull the mean to one side or another, dragging the balance point with it. Okay, I'm not going to make these two formulas because you're looking at them on your paper, but it's nice to recognize here that you have the symbols that were just discussed above to represent concepts that you're familiar with. So the sum of all the data points is sigma x over capital N for the number of data points or the population size. That would give you a mean. Add up all the numbers and divide by the number of numbers. Same with x bar, except we're just talking about a sample here, and a lowercase n for sample size. Let's do an example. It's worked out for you on your paper, but it's using the formula here so you recognize how the formula is used. Sigma x represents adding up all the data points, n represents the number of data points or the sample size 5, and since it's only 6 games we are dealing with the sample, so we call it x bar, or the mean of a sample, 26.6 points. And you see that data set or that sample represented here in a dot plot, and you can see that the mean, you can almost visualize the mean or the balance point of that of those masses, if you will, as 26.6. That seems to be correct. Okay. If you don't have a graphing calculator, use your simulator here, I would hope, and hopefully the directions were clear. Enter those into list 1. And then it's just a matter of pressing stat edit again, except this time go over to calc, one variable statistics, enter, and you'll get a lot of information. I think I said in yesterday's agenda that we want to find the mean, and the mean you would see as x bar at the very top. And I forget what the mean of this one came out to, but hopefully you were able to find that one. I didn't write it down in my notes. You tell me. I think it was 79 point something. All right, let's go ahead to the median. You know what the median is. But a couple little formulas here that are, like it says in the paper, they're more complicated than the actual concept. So I don't need you to memorize these formulas. And again, in yesterday's agenda, I said make sure there's a tilde above the X on the left of the equal sign in both cases, because it's representing the median. The X on the other side is just representing an individual data point. So we'll go through this one. That's an odd number of values in a data set. If that is the case, then we're going to take the number of values in the data set. Let's do a simple one. 1, 2, 3. 1, 2, 3 data set. It's got 3 values. It's an odd number. N represents the number of values. So it's going to be x sub 3 plus 1 over 2. That's x sub 4 over 2. X sub 4 represents the value. Oops. X sub 4 represents the 4th term in the data point. There is no 4th term, so we divide that by 2, and it's the 2nd data point. Oh, you know what? I put my division in the wrong place. Let me just erase this. I went a little too far there. I'll even use parentheses. So really we want the value of the 2nd data point in the data set. And the value of the 2nd data point in the data set is 2. Complicated way to say just find the number in the middle of an odd number of data points. All right, and the second one, yeah, even more complicated, but if you work that out, you'll find that if it's even, you take the actual number of data values divided by 2. That will give you the left side of the numbers, the 2 numbers in the middle. That will give you the left one, or the lower one. And n plus 2 divided by 2 would give you the greater number of the 2 numbers in the middle. You add those 2 together and divide by 2. Yeah, you're finding the mean of the 2 numbers in the middle of a data set, and that's how you find the median of an even number of data points. Okay, and on to the example here. Very important when you find the median, you have to have them sorted, either lowest to greatest, least to greatest, or greatest to least. And in this case, if you did that, the 27 would be in the middle. All right, moving on. You've already put the Boston Celtics heights in your graphing calculator, so if you scroll down a little bit lower on your screen, you should be able to see the median is 80. And then there's some conventions of rounding. We've talked about this before in class. Round your mean to one more place after the decimal in the data set. And what that does is it communicates the precision of the data set itself. So if you are looking at only a mean of a data set and it's rounded to tenths, then you know that the precision of the original data are integers or whole numbers. And if the mean that you're looking at is rounded to hundredths, then you know that the precision of the data set is tenths. And the median, we don't round the median if there's an odd number of values in the data set. If there's an even number of values in the data set, then we would round the median. Okay, neither one is good for nominal data. The reason for that is nominal data is categorical. It wouldn't make sense to find the mean or the median. The median works for ordinal data, but the mean does not work for ordinal data, and that's because ordinal data does not have uniform intervals between the data points. So ordinal data might be, how do you rate the internet at Kent High School on a scale of 1 to 5? The differences between 1s and 2s and 2s and 3s don't make sense. They're not necessarily the same, so the mean would be a meaningless statistic there. Interval and ratio data were okay. And then for mean and median, and there's a concept that we talked about in class there that if the data is skew, the mean is going to be pulled toward the skew, and the median would not be. So the median would be better if you have, the median would be a better measure of central tendency if you have highly skewed data sets or outliers. But if you have a more normal distribution, the mean is better because it's more sensitive. Okay, guided practice. Just going to give you the answers to these. It's asking for the mean and median. Well, if you sum those 5 numbers and divide by 5, and we're going to treat it as a sample, so we're notating it as x bar. I get 68.8 for the mean, rounded to 1 place more than the data set. And for x tilde, or the median, I get 69 when we order them. Heart rates, again, it's a sample. I get 53.8 for the mean, and for the median, 54.5. Okay. All right, this one I did not write down because we did it in class, but let me ask somebody that's in class right now if they wrote it down. Okay, I got it. We have some good students here that wrote down the results. This is meant to be done in the graphing calculator. Don't do this by hand. Just enter this in a list and then do your stat calc, one variable statistics. So the mean for this one, and again it's a sample, it says to treat it as a sample, 0.858, and then we're going to go one more place beyond the data set, 8. And the median, 0.863. And that was a positional value because there's an odd number of data points here, I believe. 25? Yeah, 25 data points. Okay, which measure of central tendency is more appropriate? Well, what do you think? Kind of hard to tell, isn't it? It's kind of hard to tell, but we did, and you can do this as well. If you graph that list as a histogram or a box plot, and you check out the shape of the distribution, you'll find it's pretty normal and symmetric. So a normal and symmetric data set, the mean would be more appropriate. Okay, sorry for the long video. Hope this helps. Take care.